So in this video, we're going to look at our first exam style question on this, which is just thinking about essentially doing work and friction and the heating we get from that. So it requires a constant force of 10 newtons to slide two identical blocks of mass 5 kilograms past each other at a steady rate due to friction, as we've drawn below. We can see we've got one block, we've got two blocks, they're exactly the same, I just put them in different colours so it's easier to see them. It's taking this force of 10 newtons and we're just moving 0.2 meters. So that's coming on here. If the top block is pushed 0.2 meters relative to the bottom block, what is the total increase of internal energy of the system? Well, this just requires us to basically use, conservation of energy and this little first law of thermodynamics thing, which we don't really need to do. We can just kind of just write down what's going on. Well, what's happening here? We're moving at a constant speed, so there's no transfer of energy to or from KE. There's no potential energy we talked about, so we don't need to think about GPE. So no kinetic energy is going away. There's no gravitational energy at play. So we just have this work being done. Work done is force times distance, remember, so FD. So in that case, it's going to be 10 newtons times 0.2 meters, which is 10 newtons times 0.2 meters, which is 2 joules of energy. But where's that going? Well, it's doing work against friction. And again, we need to go back to this statement of the first law, which is just here, which is that the change in internal energy of the system is just the total energy transferred to the system by heating it and by doing work on it. And if you consider this system as a whole, there's no external heating going on. There's no transfer of heat. There's nothing going on there. That's to say, we're not heating the system in some way. And so we see that the change in internal energy must just be the work done. So the change in internal energy is this work done. So change in internal energy is equal to W, which is equal to 2 joules. And then they ask, what is the total increase in the internal energy of each block? Well, we know that both blocks are exactly the same, so they're obviously just going to get to thermal equilibrium with each other. And because they're exactly the same, they must just both have the same thermal energy. Remember, really, we can just see, you could almost, if one of them is moving at a constant speed compared to the other, we could just think of the other one as moving with constant speed with respect to the first one. We can think of this block being stationary and this one moving, and it's kind of the same thing. So we should expect that they both have the same internal energy. And that's what we find. We find that we must just split this internal energy because they are the same, because of this thermal equilibrium that we were talking about. And because they're the same, they therefore must just have the same internal energy. They're identical. Must just halve internal energy of the system. So here we were talking about the total energy of both blocks. That's the system.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.